My name is Brian Tanner. You've joined us today for the Civil 3D for Stormwater Design webinar here at ATG. If you're joining us live, thanks for taking the time out of your day and participating in this webinar. Feel free to chat, ask questions throughout. Would love some interaction. I'll also call for questions at the end, but depending on the complexity of the question, please just understand whether or not I'm able to answer that live or we'll have to get back to you. Again, my name is Brian Tanner, Senior Technical Specialist with ATG. It's July 22nd, 2021. If you're joining us live, thanks once again. And if you're watching the recording, which you're able to do on our ATG YouTube channel, then thanks for taking time at a later date. For those who are joining us live and want to share this information with a coworker or colleague, take a peek at our ATG YouTube page and see what kind of great content we've got out there. It's usually a few business days after we have completed the webinar that it is post-processed, slightly edited for time at the beginning and end, and then uploaded for future use and things of that nature. So we'll dig right in. Just a quick note about myself. I'm from Mishawaka, Indiana. I'm a stone's throw away from the University of Notre Dame. I'm one of a handful of our permanent remote employees here at ATG on our civil services team. We've got a handful of people who work out of our main offices in Minneapolis, Phoenix, and North Little Rock, Arkansas. But we're here to serve you regardless of your time zone and geography. And we do travel when necessary and as it's safe to do so. I'm a Civil 3D certified professional, Autodesk certified instructor, and I need to update this because I think I just rounded the corner to 16 years of project experience on a range of DOT, highway, bridge, commercial site development, municipal roadway utility, and then other public resources and county resources as well. I take that experience and try to apply that to everything I do here at ATG and for our clients. Just a quick note about the different service partners that we have at ATG. We are obviously an Autodesk reseller, but we are not just an Autodesk reseller. We work with you on complete solutions from hardware to software, third-party plugins, and production services as well. So don't hesitate to reach out to us if you have questions or an interest in any of those services. Again, just to reiterate as a quick housekeeping item, if you have any questions throughout our session together, please feel free, jump into that Q&A session or the Q&A module within the Zoom session and ask a question throughout. If you use the chat, I'll try to pay attention to that as well. It's just so many windows on my screen at the same time. I may not catch everything in sequence. And the Q&A portion allows me to organize that just a little bit better as a panelist and presenter. Feel free to ask those questions at any point in time, and I will try to address them in kind of in step and in pace with what we're covering at that portion of time if I catch it and am able to notice the question. So please do so. I want to first set the record straight on what we're going to cover today, and specifically some of the just differences in how we work whenever it comes to stormwater design. We use different language. We just naturally use different language depending on what specifically we're talking about and what region that we work within, as well as how some of that terminology that we use, subbasins, watersheds, catchments, do they mean the same thing? Not precisely, but they're oftentimes used interchangeably depending on what region you're working in. However, all that said, we also have to think about our Civil 3D objects and the terminology that Civil 3D actually applies to the use of those terms. So in the case of catchment, a catchment is the object type that Civil 3D creates for a drainage area. And although I didn't specify it here within the quick PowerPoint that I put together, watersheds are an analysis style inside of a Civil 3D surface. So watersheds do exist as a term inside of Civil 3D, but it's a reference to a style used for surfaces, whereas a catchment is an actual object type with properties, with settings that can be imported and exported to other analysis software for those drainage areas. regardless of the kind of information that we're talking about today, hydrology, hydraulics, this is all collectively, in my opinion, and others on our team, I'm going to credit Kyle Groves a little bit here. It's collectively should be known as stormwater analysis. Yes, some of it's flowing through pipes, some of it's runoff on the surface, but it's all going to iterate back and forth toward the same end goal of handling that rain event, regardless of where it's being collected from and outflowed to. Now, Civil 3D itself can be set up to work better for us whenever it comes to developing these watershed areas, these catchment object types, and just drainage as a whole. We want to develop files that we can quickly export and for that matter, import to and from other design software, other analysis software. We've got HydroFlow, hydrographs, we've got storm and sanitary analysis just within the Autodesk suite, just within the tools that are available to us with our existing Autodesk licensing. InfraWorks is another one that we can tap into some analysis tools there for HECRAS and things of that nature. So we've got some tools available to us depending on our licensing structure within the Autodesk suite. Not everybody uses those Autodesk applications for their hydrology or hydraulic analysis. With that in mind, it's going to be a mixed bag. Your mileage may vary on the objects that we create within Civil 3D and how well they translate or transform between those other non-Autodesk applications. So keep that in mind. We want to configure our template. We want to configure our drawings to communicate with as much other software as we can. And using the catchments and using certain settings within the pipe networks, we can accomplish a lot of that within our Civil 3D templates. We'll talk more about that as we go along. What this webinar isn't, though, we are not going to run the analysis in external software, Autodesk or otherwise. Yes, there's HydroFlow, there is storm and sanitary analysis, et cetera, but we're talking specifically about the activity that we can do inside of Civil 3D to develop these object types and perform some analysis directly inside of Civil 3D. We certainly have our expertise in those other platforms or those supporting applications, but this particular webinar will not focus on those. It's going to focus on styles and processes inside of Civil 3D. It's also not going to focus on best practices. I am not going to tell you what the correct stormwater management plan should be for you or your region. Those regional requirements, those local and state requirements are just way too specific to dig into that. We'll talk about some of the flexibility inside of Civil 3D as far as time of concentration calculation method and what the catchments are capable of, not capable of calculating for us with that regard. So what this webinar is, it's understanding those Civil 3D object types. It's understanding the watersheds as a style, surface analysis for determining where our flow paths are and things of that nature, and the flow lines, the catchment objects, and then also pipe networks. Because while a pipe network is not explicitly required for everything that we do for catchments and stormwater drainage design, a Civil 3D pipe network can be extremely helpful whenever bringing that catchment into storm and sanitary analysis. And whenever we have pipe networks, there's certain settings that we need to do in order to match and map the types of structures that we define in Civil 3D so that they're understood as that type of object inside of storm and sanitary analysis. It just doesn't know by default that a storm manhole in Civil 3D is an open or a closed casting automatically in SSA or some of the other platforms that you may be using. It's also understanding how a template plays a role in stormwater design. It's that styles development and the pipe network parts matching that I was just referring to. So that's what this webinar is going to focus on. And it doesn't seem like too many people are jumping off of the participants list. So looks like I didn't lose you with that reality check of what this webinar is versus what it isn't. Let's jump into the demonstration. I'm not promising that we're done with the PowerPoint quite yet, but we're done with it for now, and we're just going to have a couple other things that we may touch base on as we go along. Let's talk shop about the type of drawing that we're in right now. Not a huge site, but we've got an existing site surface, and we have a proposed finished surface in this drawing for a very basic corridor. When we're doing our stormwater management design, depending on the regionality, depending on the project extents, sometimes we are also grading the site outside of the corridor. Sometimes our only part of the project is the site itself outside of the corridor. And in other times we have blended existing and proposed conditions. For the sake of this webinar and the types of procedures that you're going to run into while doing stormwater design, we're actually going to paste our existing and proposed together. Why? Because ultimately that is our finished conditions. If we're going to analyze the entire site, then we need to understand not just what we're constructing, but the areas outside of what we're constructing on what's being contributed into our project and out and away from our project. Again, depending on the type of project and the area that you're in, we may have different requirements on what we're including in that analysis. So the first thing that I would do in a drawing, and mind you, we're not working in a template. We are using the ATG starter template and the styles included in there on this data set, but we're not starting from scratch. We could spin our wheels quite a bit by trying to start from survey field to finish and then design and then start to do our watershed and catchment creation. So admittedly, there is some level of completion baked into this. What is not baked into this, what I specifically pulled out, is the creation of some certain styles that are going to help us out along the way. Because while our ATG starter template's great, I didn't want to pre-bake too many things in that we need to learn about through the webinar. So the first thing that I may do in this drawing, so I have a complete picture of what my drainage conditions are going to be, is to make sure I have a complete composite finished surface. So on my prospector tab under surfaces, I do have an EG that's probably out of date or needs some changes to it. So hopefully this will work just fine, but I'm going to create a new container surface or my composite finished grade. Name things as is descriptive and consistent as your organization needs with regard to that. Add descriptions where needed. But I'm going to go ahead and flip this. I'll leave it at the 1.1 to 5 foot major and minor increment style. I'm going to go ahead and turn off my existing and proposed surfaces to a no display style. If I had one, I may have removed that one in preparation as well. So I'm just going to go to standard and I'm going to modify that to, actually I won't need to because it's just the boundary and we can work with that. So I'm going to take that composite finish grade surface, and the first thing I'm going to do with that is I'm going to paste my existing and proposed surfaces into it. So I'm going to expand the definitions, right click edits, paste surface, and choose my EG and my top finish grade surfaces into that. Now, luckily, with the order that I selected them, everything came in the way I would expect it to. Where I have design, my design surface takes precedent and I see those design contours. Outside the limits of my design, I pick up the existing contours. If that's not the case, if you pasted those surfaces in and for whatever reason, all you see is the existing, it's because the construction order of your surface is not correct. So just to cover all of our bases, if I right click and go to surface properties, or if I select the surface in the drawing and go to surface properties from the contextual ribbon, I can go to my definition tab and ensure that the last thing that's constructed is going to take precedent over what was operated before it. My design surface is at the end of the list, so it's working the way I want it to, but I'm going to shift it for a second just to show you how this could have been done wrong and how we would resolve it. We'd go back to the surface properties and we would change the paste order of those surfaces to ensure that we actually represent the finished constructed grade of our site. Now, we've got a great site. We've got a great finished grade surface that we need to develop some stormwater design off of. Yeah, from a previous webinar, I do have some stormwater designed in here. Is it designed at the right location? I can tell you just by looking at the contours, if this was my finished design for the corridor, no, it's not at the right location. I need to have an inlet over here somewhere, and probably down at the other end of the corridor, I'm going to have some other low spots that I need to get some inlets positioned in to collect that stormwater runoff. But for the sake of our time together today, I'm not going to mess too much, if at all, with the actual stormwater layout in this drawing. We're going to talk a lot about the surface runoff and determining where our pipes need to be assigned and how to calculate those catchment areas, volumes, and time of concentrations. So with that surface active, I need to find where my drainage basins are. And by definition in Civil 3D, I need to find where those catchments are. Now, there's a few ways to go about doing this. We can either create a catchment object or we can create a watershed style. I will tell you that Civil 3D does have the ability from the Prospector tab under Catchments to create a catchment group. And after the catchment group is created, and I'll just create one as a quick example, we can right click and create a catchment from surface. And it would automatically analyze that surface and try to find all of your basins. The problem with that is there's a lot of assumptions being made, and we're already being prompted for specifying a discharge point. We don't know where that discharge point is yet. It's making a lot of assumptions that we have information that we just don't have available yet. So I'm not a big fan personally of creating catchments off of surface information unless I've already done some preliminary exploring, some digging and exploration of the actual surface data first. So I'm actually going to delete that catchment group for the time being and not create my catchment object from the surface. What I am going to do is some prep work so that I can have better data to work off of for my catchment objects, for my my flow lines and flow paths specifically. But I'm going to develop some tools and use some analysis styles of my surface to create that. First things first, I am going to select my surface. And with that surface, I'm going to go to surface properties. And inside of surface properties, you may have saw a few moments ago where I had the analysis tab open. And on the analysis tab, if you've never used it before, we've got a lot of options for how to explore the data and visualize the data of our surface in ways that allow us to make better design decisions. So I'm actually going to change it to a watersheds type that effectively is already running that catchment area automatic surface creation type of process, but it's doing it in a way that I'm creating a style that I can use and inform the actual decision on where my catchment areas are. So with the watersheds analysis type active, I really don't care about the legend at this point. I'm not going to create a legend for this. But I do want to see where my depths and things of that nature are, and if I have adjacent boundary watersheds, if those should be merged together. I'm not going to edit those. I do want to see all of my watershed areas, even with those exceptions. So I'm going to process my analysis. I am going to modify it because we see a lot of boundary points. Those are single point pieces of information and boundary segments. This is going to take care of some of those edits that we could have made there, but through, in my opinion, a simpler interface. I don't care about the boundary points or the boundary segments. I care about the depressions. I care about the flat areas. I care about the multi-drain areas. If it's inside of my project, I'm going to want to correct those multi-drain areas, but we'll talk about that here in a moment. So if I want to limit my watershed analysis down to just the actual drainage information that I need, I can click this light bulb icon as part of the range details, and I can get rid of the boundary point and boundary segment information. It's going to update my list. We see that those are all turned off uniformly. And whenever I click OK, my surface is now going to be displayed maybe in the correct style, definitely not, because I've run the analysis, but I don't see the analysis. Why not? because even though I ran the analysis, I don't have a watershed style active. I set up the configuration for it. If I go to Watershed, we can see that my configuration is still held inside of the surface data, but I don't have a visual display of that surface to visualize this information. Well, I do that back on the information tab. I'm still looking at that surface as 1 in 5 contours that I set earlier. So I either need to edit or I need to create a new surface style. Let's look at our list. It doesn't look like I have any surface styles that are going to accommodate a watershed type analysis. So what do I need to do? Create new. So I'm creating a new surface style in this drawing. Mind you, if you use it in this drawing on this project, you want to make sure that that style gets back into your template so you have it available for future use. But first things first, I always go to the display tab. I want to know what I'm seeing. I want to see those watersheds. And for that matter, I'm okay with seeing the border, the overall border of the surface, but I could turn that off if I wanted to. I'm going to look at my Watersheds tab then so that I can pinpoint down how my watersheds are styled to match that analysis that we just developed inside the surface properties. So we can look at the boundary point, the boundary segment settings. We're effectively ignoring those as we identified before with that light bulb. But then what the depressions and the flat area styling is going to be like. We can modify the styling here to override what the analysis processed earlier. These are the out of the box options, so they're going to match right now. But if our flat areas were of a major concern, we wanted them to pop, and we already use a lot of yellow line types or layers in our drawing, we could easily switch this to a different color style. We could use hatching to identify those flat areas and determine which kind of hatching was used for those flat areas if we needed to, and change the scaling and everything else. So just like any other style inside of Civil 3D, our watershed style can be tailored to fit our needs and what we need to show on plans. I think that's even the more critical aspect of it is if you need to show your watershed analysis before you ever do a catchment, before you ever do an analysis, before you ever actually calculate anything in a separate supporting software, if this is something that you need to include on a plan sheet, we can style it appropriately here. I just made one quick change to that, but we're going to see how those all apply, multi-drain, et cetera. There's going to be some more options there that we need to pay attention to. Actually, the one thing I will pull off is these flat areas. I'm going to switch that back to no hatching, just so that we stay hyper-focused on maybe some of those multi-drain watershed areas as a point of focus. So, okay, new surface style, dang it, that's my bad. I should have done a better job of going to that information tab and ensuring I created and named appropriately a watershed surface style. What do we have now? Well, we have a surface that is using a watershed analysis with a watershed display style. What good does that do us? It actually does quite a bit of good. We can see what water from what areas of our drawing are going to end up at low points. Do we know where those low points are right now? Not really, because we don't have contours turned on. We're not looking at any kind of elevation detail. We just see the overall boundary. We can tell what kind of depression or flat in the area it is based on the boundary layering that was used in the watershed style. We can even see where those multi-drain areas are. Now, this is where I'm going to jump back to the PowerPoint for a quick second, because I think we do need to identify what a multi-drain is. And to their credit, Autodesk has developed a great description and a great graphic for what a multi-drain watershed is inside of Civil 3D. And it's effectively identifying where two areas butt up against each other, and they are effectively flowing into each other in micro drains, more or less. So multi-drain watershed will show you how in this graphic, it is prioritizing how water flows from one subbasin to the other to get to a specific drainage point. So for lack of spending more time talking or reading off information from a PowerPoint. I just did want to show you this information. If you want to refer to it in the future, it is available through the Autodesk Online Support and Learning, or hey, check out our ATG YouTube channel and find the recording later. You can read it to its fullest extent at that point in time. So jumping back to Civil 3D, we've got a couple of those micro drainage areas or multi-drain areas. Now, in this particular instance, those multi-drain areas are outside of our project site. We are not responsible for them. But when you do have those as part of your project site, as you may have through several different grading groups and things of that nature, maybe where two grading groups meet, you will need to resolve that so you end up with positive drainage to an outflow or an effluent location. So keep that in mind. One of the things that I will emphasize that we're capable of doing inside of the surface that we already have in here is we're displaying that surface as a watershed surface style. But as soon as we change this surface to a different style, we lose that great watershed information. It is purely just a style. Yeah, we could create another surface. We could copy and paste a new surface. Or just use the new shell surface and paste this surface into that. But for fullest extent of understanding what capacity we have, I want to highlight a tool that I use a lot in just regular Civil 3D training, and what we need to use sometimes for shrink wrapping surface boundaries and maybe exporting to other software is our ability to extract data from a surface. Now, you can only extract data from a surface that is displayed currently. We just happen to have watersheds displayed currently, so I can go to my extract from surface dropdown in my surface contextual ribbon and extract those watersheds. I don't need to worry about the border right now. I'm just going to worry about the watershed itself. So we've got that available, and I'm going to use the OK. And it looks like nothing has changed in the drawing. That's fine. It looks like nothing's changed, but I assure you something has changed. If I escape out of the command, contextual ribbon's gone, the surface is no longer selected, I now have 3D polylines everywhere that I previously had just a surface style for those watershed areas. We also get the some labels depending on how we configured that, or we definitely get the hatching out of those, any of the watershed styles that happen to have a hatching applied to it. And we can use those to our advantage later on. So we can change the surface display style. I can go back and select that surface from a list, or do a shift select to pick that surface out from the drawing if needed. But I'm going to go to my surface properties, and I'm going to change that back to a 1 in 5 just for a moment. 1 in 5 proposed surface. So now we can see our watersheds and our contours at the same time. The one thing that might become ideal is combining watersheds in certain scenarios, because we are going to manually create our catchment areas based off of objects in our drawing. To do that, we can combine those through, I think there's a custom command, line work shrink wrap. I'm going to try it. It's been a long time since I've used it, but if I needed to combine two catchment areas, I'm going to use line work shrink wrap. There's the autocomplete for it. And it wants me to select the objects to combine. So there's one catchment area. Here's another catchment area. I can hit enter, and I should just get one large boundary around those two objects as they existed. You could continue to iterate on that line work shrink wrap to grow a much larger boundary over the, let's say, parent boundary or parent catchment areas that you wanted to define. But I'm actually going to step back a couple steps to get rid of that. There we go. Okay, so I'm back to my individual catchment areas, but it's a tool that can be very handy whenever you're presented with that need to combine your watersheds into an individual catchment area. All right, so we've got our watersheds defined. We've got them as static objects that we can use to our advantage. That also means that we can style them to our advantage. Even though they're utilizing a different layer, or sorry, a different color, they should all be on the same layer, just by the way of how they were defined within the surface style. So I'm going to make life a little easier here, and I'm going to select similar all my catchment areas, and I'm going to isolate those selected objects. Why am I doing that? Because I'm going to I'm going to do a couple things to this so I can manipulate them a little bit more easily or visualize them a little bit more easily. They're all 3D polylines. If I go to the Modify tab of the ribbon on the Design drop down, I can convert them from 3D polylines to 2D polylines. And once they're 2D polylines, I can provide them with a global width. And that's going to make them stand out and easier to select within the drawing. And I may have changed some of the draw order through that process. I could go back and manipulate that. I'm not going to worry about it for the time being. Something I definitely would pay more attention to, the draw order of those flat areas versus the multi-drain surface areas versus my positive drain areas. But I'm going to end my object isolation. It'll take just a second to process and bring all that data back. But now I have a little bit easier to identify polylines representing those watershed areas. Going to make my life a lot easier for the next thing I'm going to do. The next thing I'm going to do is try to define where my low spots are, where my high spots are. If you can read contours, great. I've been doing it long enough. I'm pretty comfortable with that. You may want to switch to yet a different surface style, an analysis style, to help out with that though. Surface properties, we'll go back, and I do believe we do have a 10 flow arrows option within this template, but just to explore that a little bit, I'm going to go in and edit that current style, make sure that the display is showing our triangles for our 10, and that we also are going to see slope arrows. Anything that's an analysis type style is going to be on the analysis tab, and I can see those slope arrows and change how they are structured inside of our analysis style and how they're going to be displayed. I'm going to switch these to an equal interval. It's going to make life just a little bit easier for the sake of our time together on how many edits I need to make once I run the analysis. But I'll say okay, and I'll go to my analysis tab and find my slope arrow analysis type, run it. I knew I was going to only come up with 3, even though I have a range number of 8, but it's because of the method that I used inside the style. And I'm just going to change. Obviously, we're going to have very, very small triangles on the faces of curbs that are at very, very large percentages of grade. We don't want that to be a portion of how our quantile or evenly distributed slopes are determined for these slope arrows that are going to show up. We may want to set more realistic ranges for 0 to 5%. 5% to maybe 12%, to where we get some of those more intermediate grade conditions, or 8.33 if you're looking for your 1 to 12 type of scenarios. And then just adjust those ranges to whatever that maximum range is at the end. We could certainly change our color coding. If it's a minimal slope, if it's nothing of major concern, we can find it. Not only is this critical for finding how dramatic our slopes are throughout the site, but it may be necessary, hint, hint, it most likely is necessary to determine your coefficients for your runoff and how that's going to affect your time of concentration. All right, and then these very high slopes, I'm going to switch to a red type. Actually, I'm going to switch this to yellow just to get it to stand apart a little bit. And I'll say okay. So now my surface style is going to swap over. Actually, I'm going to change my triangle style because that blue is overtaking everything. I'm going to go back to information, edit my style once more to where my triangle layer in this particular instance is more muted and in the background, so I can really track my flow arrows. So because we extracted our watershed areas and enlarged widened the polyline width to be able to see those jump out at us, it gives us a better idea of how the water is actually flowing, how the runoff is actually flowing on our site and in what directions. This is going to give us a key indication of approximately where the high points on our site are and where the low points on our site are. This is not the final tool that we will use to determine that, but this will expedite where we are looking for when placing the next tool, which is a water drop analysis. You could use a water drop analysis 1,000 times on a site and still not find anywhere near where your high point and low point. Well, you're going to find where your low point is, but not find where your high point necessarily is. So I use this watershed and flow analysis to determine within which catchment areas approximately where is my high point. And it's going to be somewhere right around in here. In this particular catchment area. And that circle got huge on me without anticipating it. So it's going to be somewhere in this vicinity that I'm going to end up with a high point in this catchment area. Maybe not, because we've got a little bit of a split in the flow on the site, but I'm going to use that as my basis of where I'm starting out with my next analysis tool. So I'm going to switch my surface back to a style that's a little bit more reasonable, that I can use more readily. 1 and 5 without obstructing everything else on my site. And I'm going to use that next analysis tool. Now I can use that from the Analyze tab of the ribbon. I've got flow paths, or I can select my surface again, and we're going to see water drop here. So water drop from the contextual ribbon or from the Analyze tab of the ribbon, the flow paths drop down, we have a water drop tool. With the water drop tool, it's going to ask me to select a surface that I'm going to be dropping the water on and seeing where the runoff goes to. So I'll select that surface contour that represents my combined or composite surface. And I want this to jump out at me. I don't want to just have things on layer 0 within my template, but in this particular webinar, in this drawing, I want to set a specific layer for my water drop. So I click the ellipsis, going back where it says path layer 0. I'm going to click the ellipsis, go through my layer list. I don't have a layer specifically defined for analysis yet. I'm going to create a new Z analysis layer, water drop. And I'll put that on a cyan color for that particular new layer that I'm creating. That's key. I'm creating a layer inside the command without having to get out of the command completely. Say okay. It's going to be a 2D polyline. That works to my advantage for later on compared to a 3D polyline. Do I want to place a marker at the start point? It will make it easier to find the beginning and end of your water drop analysis. So I will say yes, but I'm going to change and create a new point marker style for that. I'm just going to create a new, call it my water drop point. Marker is just going to be a basic X, and it's going to end up, I don't want a label. I don't need a label. I just want to place it, sorry, on the same layer that I'm doing my water drop line work analysis, and make sure that it ends up displaying properly. So okay, okay, okay. And now I'm actually able to start doing my water drop analysis. The key part when we are planning on developing a catchment inside of Civil 3D is you're trying to find your longest path or your highest point from the water drop analysis to your lowest point or your effluent outfall location. So when going through this process, we want to find that high point. That's why I used that slope arrow analysis before. And if I'm right here or near there, I'm going to be pretty happy with what my guesswork pointed toward. But I can use that water drop analysis 1,000 times, and it's going to help me define where my high point and my longest path is on a site. That's a good indication whenever you've got a path that splits into multiple directions, but it still ends up at a single outfall location. That's a great indication of where your catchment is going to drain toward. Again, this is predominantly just the existing contours that we're seeing out here, and then just a little bit of how our proposed grading is tying into those existing contours, leading to a drainage location. So we found that high point, or or in some cases just the longest path of our drainage, depending on what your actual goals are with the catchment. I'm only focusing on this one watershed area specifically because it would take time to iterate and build this out for everything. It doesn't take long, but longer than we have together today while I explain the use of the tools. So I will escape. Once I find my highest point or my longest path, I can simply select my point, my lines, do a select similar, and just make sure that I do not get rid of the path that I intend to keep and use for the calculation of my catchment for my flow path. This may not be the most ideal path, but it's the one I'm going to use for our time together today. One, to identify the path, and two, oh, there's actually my low point, to find that outfall location. All right, so if I've got the objects that I want, and I do now, I have my path, I have a catchment area that I can use. I just have to make sure I use the correct selection. There we go. There's my catchment area. I'm going to actually use my draw order to bring that to the top. I'm going to make that above all objects. It just should make it a little bit easier. Oh, I did not choose the correct option there. Draw order to front. There we go. So that's going to make my catchment area easier to select from that watershed boundary. So now I have the objects necessary to start doing my catchment analysis. I can do that from the Analyze tab. I can go to Catchments. I can create a catchment group. In this case, I would create a catchment group with many different catchments in it for my proposed design, the existing, and anything that's going to be impacted by my project to organize everything. Catchment group, I'm just going to say, is ATG as part of our webinar. And within that catchment group, I could continue to work off of the Analyze tab of the ribbon, or at any point in time, I can right-click and choose the options from within the prospector for creating a catchment from an object. Again, we avoided the created catchment from a surface because of some of the assumed issues that may come along with that. And because of our ability to combine watersheds into a larger catchment area or refine those. Sometimes our geometry is just weird because it's following a triangulated irregular network for a surface. So we could have taken the time to take these 2D polylines and weed some points, adjust some of the little nooks and crannies on it to simplify it a little bit, and worked toward our benefit. That's the reason why we didn't use that create a catchment from a surface option. Good, just not perfect for the types of uses that I need it for. So I can right click, or I can use the Analyze tab of the ribbon under the Catchments command button. But I'm going to create a catchment from an object. What's the polyline that defines the catchment area? Well, I moved that to the top earlier. There's my catchment. Select a polyline on the uphill end to use as a flow path. Well, that was the whole reason that we used the water drop analysis, because now we do have a flow path that can be selected in this catchment area. Now it brings us to the Create Catchment Object dialog, and I can name the catchment area. I'm just going to call this Primary East, because theoretically on this project, I may have up to 3 catchment areas for my low, high, and my corridor areas. What group that it's going to belong to, what pipe network structure, if any, we are going to reference and utilize. Again, I'm not going to use the pipe network in here unless we have just a little bit of time and I can see we're already running just a little bit short on what I would like to cover. So I'm probably going to leave the pipe network out, but I would select the network. I would select the specific structure that happens to be inside that catchment area that I want everything to drain to, ideally at that low spot. What's the catchment style? Well, we don't have any catchment styles defined in this drawing. There were, I stripped them out, but we would define a catchment style for how we want that to display. I'll just call it ATG, display on what layer, see catchment. It's going to be kind of plain Jane right now, but maybe I'll change it to bright orange so it stands out for us for the catchment boundary. And then maybe for the flow path, we use just a slightly different green or something like that to make it stand out. I'm going on the fly here. These are not the design standards that I would normally use. And then we have a new catchment style that's going to be displayed once the catchment's created. What about the catchment label? There's good information from the catchment data that we may want to reference and be able to just see at a moment's notice and glance at our drawing to find that information. Additionally, we pulled these watersheds from the surface, and I talked about using those on a plotted set of plans, but at the end of the day, you may just want to show the catchment object itself, styled appropriately labeled appropriately on your set of plans. So we can absolutely address what those labels look like here, so that whenever you've got your stormwater management plan, it's already styled to display correctly on those plans. But we could spend another session at another time talking about all of the idiosyncrasies of label components and things of that nature. Just realize that within a label component, there's quite a bit of data that we can pull from the catchment object itself that can be included in the label that's displayed. So without going too in depth about all of those components and how you can configure the offsets and text size and fixed or static text versus dynamic text and things of that nature, that's for another webinar at another time. Same thing for the flow segment labels versus the catchment label style. Before we get completed with this, yeah, there's a runoff coefficient. Unfortunately, this is going to be just the one value that you can assign to this catchment area, is just the average runoff coefficient for the entire catchment. So if you've got asphalt, if you've got grass, if you've got tall grass versus wooded area, and you've got different coefficients within the Civil 3D object types, you either need to break those down into smaller catchment areas that identify those coefficients different, or do what some regions allow, which is average based on percentage of use, what those coefficients actually are within that one catchment area. So if you got 50% asphalt versus 25% grass versus 25% wooded, you would find that composite value of the runoff coefficient and establish that here. I am not going to erase my existing entities, because in my particular example, I've already defined the boundary the way I wanted it to with the watershed style and the extraction of that polyline. But you could, once you've used those watersheds to extract the data and create your catchment, you could absolutely get rid of that watershed boundary and just use your catchment styling to address the way it looks on the set of plans. But we also want to make sure that we don't miss this flow path tab. The flow path tab is more of a check than anything, because inside of Civil 3D, the only calculation method that we have is TR55. You can create a user-defined calculation method, but you're going to be doing some work on what that actually represents. And you better know what you're doing to make that assessment or to define that value. So TR55 is the default method for calculation of time and concentration. We are going to use the object that we pulled, meaning our flow path that was defined. If we did not choose that, if we did not have a flow path, we could have pulled it from surface. And again, we would have been dealing with Civil 3D determining if, when, where, how that flow path was calculated automatically. I'm not saying it does a bad job. We just don't get to make any decisions. We don't have the opportunity to edit or manipulate that polyline that we would have had from the flow path that we created using that water drop tool. So we've got all the settings adapted. We've got the catchment, the flow path settings for naming it. Technically speaking, we could have developed that reference pipe network and the specific structure that was going to be calculated for outfall. And we'll click OK. All right, select a polyline for a catchment area boundary. What does that mean? Well, you're on to the next one. We're adding catchments collectively to the group that we have already established. Autodesk and Civil 3D assumes that if you've got one catchment, you're going to have more. In this case, again, for the sake of time, I'm going to just escape out of the command, and we will see that once I select the flow path, it also selects the entire boundary of the catchment as well. If I look at the contextual ribbon, I actually have that catchment name identified, and we can look at the catchment properties. We can adjust any of those coefficient values. We can adjust the flow paths. We can move from one catchment group to another if we need to reorganize our set of plans or the way that we've organized our proposed versus existing catchment areas, if that's a part of our analysis. And then lastly, we need to think about how we are connecting this data from the catchment that we just created. And actually, let me go back really quick, because the catchment properties, we have the style itself, and then we've got the catchment properties that brings up a dialog for us to visualize and edit some of those values, and also see what some of the actual analysis was. What was the distance of that flow path, that hydraulically most distant flow path, and the length and things of that nature, the area that's being determined. These are uneditable features in some cases because that's just part of the data. If we redefine the boundary of the catchment, well, that data would update. So we've got those properties. We've also got the editor itself. If I expand and expand, we can right click and go to those same properties from the prospector. Let's see here, the editor itself. And we can then look at the Analyze tab for how we're bringing this in and out of other software. Now, one of the things that we can do is that time of concentration. We can expand our design panel of the Analyze tab, and you can see where we can launch the Express tools, and we can hydroflow calculate what those catchment areas are. It's going to look at that information. It's going to look for our hydrology. It's going to allow us to define the method used and pull that information from inside of that catchment or multiple catchments that we've utilized. Again, this webinar is not intended to be about that. There's obviously an entire session, entire hours, plural, that could be spent on how hydroflow, hydrographs, storm sewers, and everything else for those analysis plugins or analysis applications and how we could interact with them. But the data that we needed to define is already configured for this catchment, and that could be repeated for multiple catchments. The other thing that needs to be configured in Civil 3D, if and when we export this out to Storm and Sanitary Analysis, for instance, for everything to connect, is our pipe network part matching. And for the pipe network part matching, we would need to go to the settings. And again, in our template, we would define this not on a per project basis, preferably, because it is time consuming. You only want to have to do it once and have it carried forward in perpetuity. But we would right click our pipe network node, edit feature settings. That happened to pop up in my other screen. And then expand to the part matching information that we actually need to assess. Storm sewers, migration defaults. What are my part matching defaults? Well, I don't have any defined right now. If I select in that column for part matching defaults and then select the ellipsis button, again, popped up in my other window, or my other screen rather, now I can define how my pipe network parts are going to be translated during an import from Storm and Sanitary Analysis to Civil 3D, or from Civil 3D out to Storm and Sanitary Analysis. Depending on the type of part that you have, the Civil 3D part type column, maybe you use a rectangular junction structure, no frame, for your inlets or your catch basins. We need to make sure that whenever that's brought into Storm and Sanitary Analysis, that it's not a manhole circular object, but rather that it is a great inlet rectangular in this case, because it is a rectangular junction structure. That way, Storm and Sanitary Analysis knows that it is an inlet, that it does have a grate, that it's not a closed casting, and how to include that in the calculation. So grate, inlet, rectangular. We have to go through and map these structure types from Civil 3D to Storm and Sanitary Analysis. And then same thing for our pipes. Is it a circular pipe? Well, sure, it's a circular pipe, but sometimes we do have elliptical or egg-shaped pipes or box structures that need to be accounted for our pipe mapping as well. So I tend to go through my export list first, come back to my import tab, and then map those things back to Civil 3D, what those SSA part types are toward my Civil 3D part types. I'll say, okay, very few changes there, but I'll use what I've got. Now for the parts list used for migration, what parts list inside of Civil 3D am I actually going to take advantage of? Not just something blandly, certainly not pressure pipe. How about our actual stormwater parts list? We want to have something that's relative to the type of calculations that we're doing. And just because we called it stormwater does not mean that Civil 3D automatically understands that that is a storm drainage list. We can name it XYZ W12 ABC 123. It doesn't matter. Autodesk and Civil 3D does not automatically assume what we name parts list and how they should be assigned to the migration of those parts from the analysis software back into Civil 3D and vice versa. So we can part family swap from those settings. We can map them to a particular parts list, and that just makes life a whole lot easier, because if we did have an inlet that was assigned as the outfall for this catchment and brought it into SSA, it allows us to do work in SSA much more quickly, because it's already recognized as an inlet, it's already recognized as a rectangular structure, it's already recognized as having an open grate. We may want to go into the specifics of what grate exactly it's going to have, what its actual open area is for drainage purposes, and how much water it can take on, the rate of inflow. So those kinds of things we may specify further inside of SSA, but we are going to have a lot of our settings already pre-configured, because we've gone through our template in the pipe network feature settings and mapped our sewer migration details. And again, that was the purpose of our time together today. It was, how can we set up Civil 3D to do stormwater design and analysis better for our workflows? Did we go through a lot of actual stormwater design and analysis in detail? No. And that's what I tried to underscore earlier on in the webinar, is that this was not going to be about that. It was about setting up Civil 3D to do those things for you, and how to develop some styles to work to your benefit to expedite that process. So parts mapping, watershed extraction from a surface, slope arrows for determining and making best judgment for where your high points or your longest path will be for a watershed analysis, our water drop analysis tool for finding that longest path, setting up those watershed boundaries and the longest path as 2D polylines, so that they can be easily edited and manipulated to work for us if they needed to be combined or simplified, and then applied to the catchment object. That catchment object having all of that in that critical coefficient and time of concentration calculation information embedded into it, so that whenever we go to storm sewers, if we go to our design dropdown and launch storm sewers, how we're actually going to evaluate those networks and then evaluate those catchment areas. We're just making that process much easier for ourselves. Now, with that said, I've got just a couple more details to touch on within the PowerPoint, maybe jump back into the software very, very briefly. But if you happen to have any questions, now's the time to ask, because we will end our session together in the very near future. So jumping ahead, if you did want to learn more, my colleague Kyle Groves has developed a very detailed white paper regarding what we've talked about today. Some of us learn better by reading. Some of us learn better by watching. Some of us need a little bit of both to have a more comprehensive understanding of how a tool works. Go check out this. I know it's a long path, it's a long link, but it's worth your time to take a screen grab and look at it. Check out the YouTube video that's going to be uploaded in a few days, and use this link to path to how to access and download that white paper that goes through this process in a little bit greater detail than what we could possibly cover in an hour of time together. And barring any questions, I'm not seeing any pop up through the chat or through the Q&A section. I'll just keep rambling on for a couple more minutes, but please feel free. I've mentioned the YouTube channel more than once, but you can also connect with and follow ATG USA on LinkedIn. That's going to give you kind of a notification of when things are coming your way, as far as our webinars, our white papers, our blog posts, and things of that nature. Because while we pride ourselves in quality services to our clients, we also want to reinforce the tools that we should all be aware of and provide some information about that freely to all users of this great Autodesk software that we love to use. Okay, I do have a question from Arena. If I add many break lines to a surface using specific values and supplementing factors, can I edit those values later, or do I have to delete the feature lines from the surface and add them again? Yes, I think you understood the context, Rana, of this being unrelated, but if you add a lot of break lines to a surface, Assuming that those break lines are feature lines or 3D polylines, you can simply change those feature lines or 3D polylines and their vertical information or the points of inflection. They may just have vertical points, not necessarily vertices. And you can make those edits, update your surface. The one thing that will not update automatically is if we created our catchment from a manual extraction of those watershed areas, we would probably need to update those watershed areas through going back to a watershed surface style and then extracting those watershed areas again. So this is kind of an iterative process. Actually, I think I even used the word iterative in one of the earlier slides, that as we modify our design and go through some value engineering, that we do have to address some of the changes to our design that we have to make to ensure that we are not leaving little micro ponding and pooling on a site. So yeah, you can update your break line information. The surface will update automatically. Your watershed analysis style, whenever you make that active again, will update automatically. It's just a matter of re-extracting that information to recreate the actual catchment object with the updated boundary. Alternatively, if you know where that boundary is at, you already have the catchment area. It would be a lot of vertices to change, but technically speaking, you could take every vertex, and let me jump back to it just so it's plainly obvious. I do have that catchment area. If the catchment area needed to update to match the watershed, let's say the watershed went to this corner, I could go through and manually change my catchment area. I just think that with the amount of nodes or vertices that get included in the catchment, you'd be better served by simply pulling those watershed areas back out of your surface style and reassigning that as the new catchment area. That's my personal opinion. Joel, I'd love to see part 2 where you take this information into the Analyze Gravity Network tool. I agree with you, Joel. That's something that we might do at a future date. I do know that we plan our webinars several months in advance, so I can't promise that anytime soon. But that is something that I think that we can and arguably could offer as a webinar at a future date. So thanks for asking that question and suggesting the Analyze Gravity Network tool in a future webinar. So flip back to the PowerPoint really quick and just end, because I think those were the only 2 questions that we had, and we are a few minutes past the top of the hour. And I just want to thank you again for your time. If you needed to reach out to me, you had a desire to connect, please feel free to on LinkedIn. I'm just linkedin.com/in, whatever they do. And my username is Brian Tanner, or there's my email address at the bottom of the slide. And I just wanted to tell you that I appreciate your time, appreciate your feedback, and feel free to connect with us on LinkedIn, follow us on our YouTube page, and see all the great content that we put out, at least on a weekly basis, to our viewers. Thanks so much. Take care and talk soon.